sum and difference of powers. We have actually talked about this before. Right? If you have a to the power of n minus b to the power of n, then it can always be factorised starting with a minus b, and then the powers of a will go down by 1, and the powers of b will go up by 1. Okay? And we saw, the first one we saw of that, I guess, was the difference of two squares, where it was simply a squared minus b squared. Then the power of a would go up by 1, so it's a to the power of 1 plus b to the power of 1. And did I write that down? Oh, I didn't. Then we had difference of two cubes, and if you think of difference of two cubes, it went a minus b. Then it went a squared. Then the power of a goes down by 1, a, power of b goes up by 1, ab. Then the next one, power of a goes down by 1, so we're now down to a to the power of 0 times b squared, and that's where that one came from. And that pattern carries through for all of them. Now, if it was plus b to the power of n, then the only difference is in the second one, the signs alternate plus minus plus minus. But there is a problem with this one, and it only works for odd numbers. Right? You don't have a sum of two squares, for instance. You can't factorise that neatly, the a squared plus b squared. In fact, you'll remember we came up with an idea, so we could find that, where we said, oh, well, that would be the same as a plus b all squared minus 2ab, but it's not a nice, neat factorisation. So the sum one only works if the power's odd. So if I had to factorise x to the power of 5 minus 32, which technically, I'm not saying you'd write this down, I mean, that's what we're thinking. Okay, well, 32 is 2 to the power of 5. So I know it will start with x minus 2. Then the powers of x will go down by 1, so it's x to the power of 4. And the powers of 2 will go up by 1. So the next one's 2 to the power of 1, x to the power of 3. 2 to the power of 2, x to the power of 2. 2 to the power of 3, x to the power of 1. 2 to the power of 4, x to the power of 0. There's our factorisation. In fact, later on when we talk a bit more about polynomials, we'll see that this second one will factorise, because every polynomial can be factorised down to a combination of linear factors and quadratic factors. So anything bigger than a quadratic can be factorised down further. But that's all we're really concerned with at the moment, just that piece there. There you go. Touch it real quick.